Excellent. Good evening, everybody. We're back here. Again, I had proven these formulas last time. This formula here, we proved, right? This formula can be proven similar to that. This is what happens when you take the ratio of these two formulas. These here and these make up what 6.4 is. 6.4 is just about the rest of those formulas. And so those formulas come directly from these when you add and subtract these. So this is something that we're skipping only because these formulas don't come up that often. Again, I'll take a look at the final to make sure none of that's on there, but I would be stunned if the person whose shell this is skipped this and it's stuff on the final. But those are basically obscure formulas that the bottom line is that when you're working through this stuff, right, you just need to know that there are tons of formulas that you could use so that the point is that if you ever come across sine alpha times sine beta, it could be something else in terms of cosines and so forth, right? Or if you see the sum of sines, basically if you're reading a paper, right, and you see that somebody says that the sine of alpha plus the sine of beta, and all of a sudden they start writing it as the sine of something else times the cosine of something else, then you need to go find this cheat sheet to make sure that they're using a formula that you are aware of. Okay. So 6.3 has to do with these formulas here. So 6.3 we'll do these, and where are the other ones? Double angle, and these. We're doing these today. Okay. So we're doing those formulas, and then that will be the end of the sheet, right? Those are the only ones we're doing on this sheet, and then we're going to solve some trig equations, which is 6.5. Okay, and that will be all of chapter 6. Again, we're just braving through the fact that this is the space where we have decided pedagogically in mathematics to talk about trig, and so it's just bombarding you with all this trig stuff, okay? Yeah, so I'm going to derive all these formulas, and then we'll use them in the first homework, take a break, solve some equations with the second homework. When you're solving equations, we'll need to use the unit circle, so we'll also use that. Okay, let's do the double angle formulas first. Let's prove these. And so we will, are we in the homework section? Let's go over here to class lecture. All right, so we're here. So we need to show that. So let's remember last time we said that the sine of alpha plus beta is equal to sine alpha cosine beta plus sine beta cosine alpha, right? And so when you're doing sine of 2 theta, we actually showed this in the homework last time. This is just the sine of theta plus theta. So this is equal to sine by this formula, right? So by this formula, this is equal to sine theta cosine theta plus sine theta cosine theta. And so this is 2 sine theta cosine theta. Right? So that whenever you see the sine of twice an angle, you can always reduce it by looking at 2 times the sine of the actual angle times the cosine of the actual angle. We also said last time that, so that's one formula. You use this in calc a lot, actually, when you're trying to deal with the sine of twice an angle. So this comes up, maybe not a lot, but 3 or 4 times someone will invoke this formula for the sine of twice an angle. We also learned last time that the cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. We said that last time. So that if I want to know the cosine of 2 theta, it's the cosine of 2 theta is theta plus theta, and use this rule again. It's the cosine of theta minus the sine of theta, the sine of theta. Cosine of 2 theta is really cosine squared minus sine squared. This is how you handle taking the cosine of twice an angle. They have two other formulas. You see how they get these other formulas for this? It's almost like an identity, right? We know that sine squared is what? 1 minus cosine squared. So two other identities you could use is that this is cosine squared minus, and then this is 1 minus cosine squared by the Pythagorean identity. So this is equal to cosine squared theta plus 1. I'm sorry, that's minus 1 still. That's not ominous at all. Cosine squared theta minus 1 plus cosine squared theta. That makes 2 of them. So this is 2 cosine squared theta minus 1. And you can also have replaced this cosine squared with 1 minus sine squared. So I could have gone here, let's use a different color. Or I could have gone to this very same step and replaced cosine squared with 1 minus sine squared. 1 minus sine squared, and then got a different formula, minus sine squared. And so this is equal to 1 minus 2 sine squared. And thus we have all 3 different formulations of the same formula. Let me put this in a, I don't use this pink that often. Wait, what's this one? Orange. Let's use red. So here's one, like that one was the first one. This one was the second one. Formula, and here is the third one, right? Double angle identities. Tangent formula comes from what we said last week. We said that the tangent of alpha plus beta, this is the one I rarely remember, it's the tangent of alpha plus the tangent of beta, all over 1 minus tangent alpha, tangent beta. We said that last week. I'm liking this orange. The tangent of 2 theta, therefore, is just the tangent of alpha plus alpha, and that's going to be tangent theta. Oh, well, tangent of 2 theta is tangent of theta plus theta. That's tangent theta plus tangent theta all over 1 minus tangent theta times tangent theta, and then it follows, the formula follows pretty quickly. Right? So then that's 2 tangent theta all over 1 minus tangent squared. Right? So that just derives all the formulas, right? Again, in the context that we have, you know, when you're tested on this, you'll have this cheat sheet all in front of you. Again, across this nation in various pre-calculus places, whether it's in high school or it's in college, you know, every teacher's just deciding whether they're going to have their, you know, students memorize this stuff, right? I'm of the mind to be realistic that, again, when you're in the future and you need to know this stuff, right, then you just go find the cheat sheet. The real challenge will be when you are in calculus. And when we're going to solve equations today, that's going to be the issue. They're going to be, and it's going to be like 17% of your calculus problems are going to be trig problems, right? Where someone's going to be asking how fast is this cosine function changing at pi over 3? You're going to do all this great calculus work, and then at some point, at the end of this, you're going to have to take the sine of pi over 3, right? And you're right, at some point, and then at some point, you're going to have to know that, right? And that's usually when you really want to learn the circle. Because then if you don't have it right, then someone takes off 3 points, right? Because you don't know the sine of pi over 3, right? So this is not the space where you're going to have it down cold. It's when you're in calculus and they're using sines and cosines and you have to learn it, right? So, yeah. Or it's going to be when someone's going to prove that the derivative of sine is cosine, and then they use one of these trig identities to do it, right? And you're going to say, all I want you to know is like, oh, I know that there is a trig identity like that. I've seen that before, right? And then as opposed to some of your classmates like, wait, how did you get that? I've never seen that before, right? It's my duty to make sure you see it. All right, let's hit the homework. Oh, let's do the half angle. So then, if I want to know, for instance, the sine of 15 degrees, well, 15 degrees is half of 30, so maybe I could say something about that. Half angle formulas. Where are you, cheat sheet? Oh, you're back over here. Half angle formulas. These over here. Half angle formulas are pretty, let's use this right here. They are pretty clear, because when you see an angle like 15 degrees with 22 and a half, it's clear that 15 is half of 30, 22 and a half is half of 45, and these are angles that are on the circle. All right, so we just showed that the sine of, let's do the sine one. We just showed that, let's do this. We just showed that cosine squared 2 theta, I'm sorry. We just showed that the cosine of 2 theta is equal to 1 minus 2 cosine squared theta, right? And so what I want to do is I want to let W be 2 theta. Then what exactly is theta? If W is 2 theta, what's theta? W over 2, right? So if we rewrote this, then it would say that the cosine of W equals 1 minus the cosine squared of W over 2. And so now what we can do is we can find a formula for this. What is the cosine of W over 2? Right? And so all we're going to do is solve for this thing now, right? So we subtract 1 on both sides. Cosine W minus 1 equals negative cosine squared of W over 2. Change the signs. 1 minus cosine W equals cosine. I'm sorry, this formula is wrong, right? This is 2 cosine squared theta minus 1. That's the formula. So then this is cosine 2 theta is 2 cosine squared theta minus 1. So then this is plus and that's minus. Right? And then this is plus and that's plus. Okay. And this is cosine squared omega over 2. You take this, and then there's a 2 in front of here, right? 2, 2, 2. Divide everything by 2. 1 plus cosine omega over 2 is equal to cosine squared omega over 2. And then finally, the cosine of omega over 2 is equal to plus or minus the square root of 1 plus cosine omega over 2. And so that's the first formula. You can get the other formulas in similar ways. So if I wanted to know the cosine, so let's write the 1 for sine. The proof goes very similar. So the 1 for sine is the sine of half an angle is equal to plus or minus the square root of 1 minus cosine omega over 2. And tangent, you just take the ratio. So if we want to know the sine of 15 degrees, right, that's equal to the sine, the angle here is 30, and so that would be equal to plus or minus the square root of 1 minus the cosine of 30 degrees over 2, right, whatever ugly thing that is. Right? Which one is it, plus or minus? Well, 15 degrees is clearly in the first quadrant, so it's plus. Homework number 1, just 15 problems just using these formulas. Let's burn through it. Six, 3.
Just go back like 2 seconds.
Absolutely, thank you. So yeah, so again, the point is that this is on the circle, right, on the circle. And then now this, so that the sine and cosine 15 degrees is not completely ignorant to us. We can actually get the exact answer for what the sine of 15 degrees is by working through that. Go ahead.
If you go above,
Yeah.
it says cosine w plus 1 equals minus 2 cosine squared. Is that?
Now this is plus. This is
Okay.
also plus, right? Because we added that over. That's plus.
Okay.
Yeah, that's right.
So I was wondering, I was like,
Yeah.
did he just change the sign? or-
No, no. Yeah, we just wrote the formula wrong at the
Okay.
beginning. Yeah.
Sorry, thank you.
Oh, no worries. Thank you. Excellent. There's a triangle. Let's make it bigger. There's a triangle. What's the sine of 2 theta? Well, now we have this formula. Sine 2 theta is 2 sine theta cosine theta. And so really they're just asking you to find the sine of this angle, the cosine of this angle, and multiply. I've zoomed in, so I should decrease the thickness of this thing. So then we know, so this is going to be 2 times, what's the sine of this angle? Opposite over hypotenuse times the cosine of the angle, 15, right? And now this becomes an exercise in reducing 625, 600, 25 goes in that how many times? So then that's 120 over 125, right? Okay. 5 more, 24 over, I'm not 24. 5 goes into 120, oh maybe it is.
It'll be 12 over 2 times.
Is it 24 over 25?
12 over 2.
12 over 25? This is closer than half, right? 120 over 125?
Is it 2 times?
So
Oh, is it 2 times 20 over, okay, cool, sorry.
yeah,
I made a mistake there.
yeah, 24 over 25.
Yep.
It just reduces, yeah.
I didn't see the 2 in front, so.
Oh, yeah, yeah,
Yeah.
so you multiply by 2. Yeah, that's how we got 600, yeah. Same thing. All of this using the formula, right? So tangent of 2 theta, what now we know is tangent is 2 tangent theta over 1 minus tangent squared. So then the question becomes, how bad do these fraction problems become, right? So this is where, you know, get your calculator game on for sure, right? So then the tangent of this angle is opposite over adjacent, right? So yeah, it's just annoying. 215 over 8 over 1 minus 15 over 8 squared, and use whatever device you want to reduce this fraction, right? That's what it needs to be. Oh, trick, cheat sheet. Here you have a choice of which one to use. You have 3 choices. I see no reason really to use this one, right? So you can use that one. I almost prefer this one. Or this one, only because in each of these you only need to find one trig function, right? For this first one you need to find both of them, and it's just easy to use one. So what's the cosine of this angle? The cosine of this angle is adjacent. Oh, they don't even tell us the hypotenuse, right? 6, 8. 6, 8. We know 3, 4. All right, we'll call it Z. It is 10. Right, so if you didn't know what it was, use Pythagorean theorem. 6, 8, 10. And so, yeah, so it's 2 times cosine is 8 over 10 squared minus 1, whatever that number is. Questions there? All flat out formulas. I'm going to tell you that sine is that. Right, so then what are these other things? I'm going to have to take this one and give it its own page. So he's playing around the trig. Let me make a new page. Let me paste. Okay. Game plan, I hope, is straightforward. One, we know that we need to find cosine. Right? So find the cosine of theta, and then it's just use the formulas. All right. So again, that's 2 sine theta, cosine theta. This one is 1 minus 2 sine squared theta. This one is the ratio of these two. Once you get the answers to both of those, you just put them over each other. Right. Hopefully it looks nice. Or this has its own formula, of course, but it shouldn't matter. All right, so if sine is 11 over 20, we're talking about a triangle like this, right? And 20 is the hypotenuse, 11 is the opposite. This number is not nice. It is z squared plus 11 squared equals 400, right? Z squared plus 121 equals 400, and that one is just not looking nice at all. 179, no, 279. That might work out. What number is that? Using a 3, right? Is that 27? No, that's not 27. 17? No.
16.7?
No, it's bad. So z equals the square root. But 9 goes into it, right? 279, 9 times 31. Unfortunately, I think my math lab likes 3 to the square root of 31. They are not going to like for you to keep 279 in there. So here, just watch out for that type of reducing. It prefers 3 to the square root of 31. And therefore, the cosine of this angle is a very funky 3 square root of 31 over 20. So that's the intermediate piece, and then again, we just burn through the formula. So then, now that we have sine, let me rewrite it. Oh, I'm sorry, quadrant. What quadrant are we in? Quadrant 2. Is this positive or negative? Negative. Because we're in quadrant 2. So that now, we're golden. Sine, let's remember, is 11 over 20. So then then the sine of 2 theta is 2 sine theta cosine theta, and we have both of those now. That's 2 times 11 over 20 times negative 3 square root of 31 over 20. And it's just about how bad we need to write this thing. So that's negative 66 square root of 31 over 400. That's negative 33 square root of 31 over 200. Questions there about that? It's all formula. Cosine 2 theta, if you do 1 minus 2 sine squared theta, right? Then we already had sine, and it was already nice, so that's why I used it. It's the one that was given. It's 2 times 11 over 20 squared, right? So 1 minus 2 times 121 over 400, 1 minus 242 over 400, 400 over 400, 158 over 400. At this point, this is all calculator. Just put this in the calculator and make it a fraction. 158 over 400, 79 over 200. The only hope is that when now you do sine over cosine, you get something nice for part C. Right? So for tangent of 2 theta, it's just, again, it has its own formula. but you've already done nearly all the work. To tangents, the ratio of sine over cosine. Sine was as ugly as it gets, right? The off the record remark is that all these denominators usually cancel, right? So then you're just left with this thing. Arbitrary formulas. I'll take questions about any of those things. Let's roll on. Oh, that was a separate sheet. So we're here, right? Good. So we did that one. Okay, excellent. So 5. What is that? So we're going backwards. And so we're supposed to see that, we're supposed to remember, you do enough of these, right? You'll see this. All right, so that's this. So what is this trying to hide? That this is really the sine of what angle? Twice this angle. This is really the sine of 150. Right, so then it's that choice. It's the sine of 150 degrees. Sine of 150. Sine of 150. Now we know it's either 1/2 or it's the square root of 3 over 2. Which one is it?
1/2. Yeah.
It's 1/2. Can you see why? Right, because when you look at the circle, 1/2 is close to what? How does it make sense? Right? 1/2 is close, I'm sorry, 150 is close to what? 180, right? Which one over here is bigger, the x or the y coordinate? The x. So the y coordinate has to be smaller. That's why it's 1/2. Smaller in absolute value without the sign. So just recognizing. What's that one?
Cosine.
That's the cosine of 150, which we now know. It's in the second quadrant, so that's 150. And if it's in the second quadrant, it's negative, and by the same argument, it's the square root of 3 over 2. So again, just using the formulas, understanding when they're seen. Right? What is that trying to hide? Who knows, right? Tangent of 2 times 3 pi over 8. That's the formula for double angle for tangent. That's the tangent of 3 pi over 4. That's equal to, again, you would just look at the circle. This is the y coordinate over the x coordinate on the circle. The y coordinate is the square root of 2 over 2. The x coordinate is minus the square root of 2 over 2. That is negative 1. So in terms of the answer choices, it's tangent 3 pi over 4. And then, just looking at it, it's negative 1, taking the y coordinate over the x coordinate. All right, verifying the identity. I have no idea how they're going to go from left to right. This is almost impossible. I almost want to go from right to left. So, and I almost want to do this by process of elimination. I can't believe I didn't take this problem out. Okay, so let's see which ones are actually true. And I do want to move from right to left here because it's easier to see how this changes to this than somehow, like this step right here, how in the world can you see how this becomes this, right? That's really hard to see. But there's some mistakes here, okay? So here, like, why this one can't be right is because 1 plus cotangent squared is not secant squared, right? 1 plus tangent squared is secant squared, so that is wrong. 1 plus cotangent squared is cosecant squared. This just remain right, and then this looks right, right? So then the only question is, why is that true, right? Can we find some mistakes elsewhere? These two are not equal, right? So it's not that. And this looks good, but these two are not equal. So you can just get that from process of elimination. I actually do want to go ahead and offer some extra credit on this equal sign. Why is it that cosine squared minus sine squared is equal to cotangent squared minus 1 over cosecant squared? I actually don't think it's that bad to show it. But we'll go ahead, since it's even or odd. Even will make it worth 4 points. You got, I was going to say 3 if you had said odd, but you won. So show that why those two are equal. I'll add 4 points so far. I didn't tell you I had a problem with extra credit. I just like giving extra credit.
So you can turn in both of them?
Absolutely, 9 points. I'll add to the test. Why is cotangent squared theta minus 1 over cosecant squared equal to? It looks like we have one thing that we're turning into two things. So we know what to do when that happens, I think. And then, yeah, it should come out. Oh, let me label this extra credit in case somebody clicks on the link and D2L and comes to the notes. Oh, shouldn't I put it on this page too? I should label this page extra credit somewhere. Oh, this page is too long though. You should just know that it's in 6.3. Extra credit is in 6.3. Here's another identity. This one shouldn't be so bad, right? So 1 plus cosine 2x is equal to 1 plus, and then cosine 2x is 2 cosine squared x minus 1. It's equal to 1 plus 2 cosine squared x minus 1. The ones cancel, and that's 2 cosine squared x, right? So let's see how this is going to work. To transform the left side into the right side, blank should be changed to blank and then simplified. So it sounds like I changed the cosine 2x to 2 cosine squared minus 1, right? And then simplify. That's all I was asking. All right, so we're going to try and reduce the powers here. What's the current power on this? 2, right? So use the power reducing formula to rewrite the expression as an equivalent expression that does not contain powers of trigonometric functions greater than 1. Let's see what we can do here. This is a Calc 2 question. We're going to ask something about this thing and say we don't want the powers this high, and so let's make them smaller. Let's add a page here. All right, and so we have that. Oh, so let's look on the cheat sheet. I think they're referencing something on the cheat sheet, and it's these here. That these are ways of reducing powers to things that have less powers, right? So the power, so you're trading the power on the sign by doubling the angle. By doubling the angle. Okay. And so we're going to use these. So we'll use both of those. Right. So this is going to be long, but good. All right, so then I'll put it here, right? Yeah. So then we're going to use both of those. Okay, so then we can write this using both of those as 96 times, and then the first one is 1/2 times 1 minus the cosine of 2x, and the other one is 1/2 times 1 plus the cosine of 2x. So we've reduced these powers of 2 down to one thing. Now, I think they're going to want us to multiply. And so when you multiply these two, you get 96. Well, first of all, 1/2 of a half is a fourth. A fourth of 96 is 24. All these numbers in front become that. 1 minus cosine 2x. 1 plus cosine 2x. When you multiply, it's 24 times 1 minus cosine squared 2x. Again, now we have this power, and we need to reduce again, and so we'll just use this one more time. Okay, so then it's 24 times 1 minus 1/2 times 1 plus the cosine of what? Not 2x, it's already 2x. I need to double the angle. It's 4x. Then it becomes, and who knows how much they want you to simplify, but it becomes this. It then becomes this. And now there are no powers. I need a 12 here. So that 96 sine squared cosine squared is just 12 minus 12 cosine 4x. So really, for even powers, there's no need to really have even powers at all on sines and cosines. You can always make them just regular sines and cosines of multiples of the angle. If I graph both of these functions, they look identical. Questions there, again, using the formulas and just going through the work of reducing. Wherever you see a power, just use one of these formulas. Here. 105, half an angle. 105 is half of 210. It's really half of 210. The cosine of 105 is equal to the cosine of 210 over 2. The formula says that the cosine of alpha over 2 is equal to plus or minus the square root of 1 plus the cosine of alpha over 2. This is going to be equal to plus or minus the square root of 1 plus the cosine of 210 degrees over 2. Okay. The only problem is how bad this square root looks like. Okay. So then, first of all, is it plus or minus? 105 degrees
Minus.
is in the second quadrant, so it's the minus, right? So the answer is minus. And then now we've got a super bad problem with these square roots. Let's see. So the cosine of 210, what's the x-coordinate at 210? Oh, it is minus, that's right. At 210, yes, in the third quadrant. 210 is basically, the reference angle is 30 degrees. So it's got to be a square root of 3 over 2. And it's minus square root of 3 over 2, all over 2. That's too thick. And so now it's this nonsense, right? You got to make this look nice. So then we've got a 2 over 2 minus the square root of 3 over 2 all over 2. We've got a square root of 2 minus the square root of 3 over 2 all over 2. Right. And there are a few calculators that will just do all this nonsense for you. 2 minus the square root of 3 over 4. The 4 goes free. The square root of 2 minus the square root of 3. The square root of 2 minus the square root of 3 all over 2. That's a super ugly thing. Yeah. So the key is just recognizing that 105 is half of 210 using the formula again. Same thing here. sine of alpha over 2. Sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine, this is alpha over 2, cosine of alpha all over 2. So really this is asking us what's the cosine of alpha adjacent over, right? Oh, 11, 60, 61. I did not know that one. 11, 60, 61. Square root of 1, all of these are positive, right? Because the angle, all the angles are between 0 and 90, because it's part of a triangle. So it's plus 1 minus 11 over 61 over 2, and you just figure out the calculator stuff, right? So again, this is not going to want us to have these radicals in the denominator, right? Rationalize, that's super ugly. Square root of 50 over 61 over 2, square root of 50 over 126, square root of 25 over 63, 5 over the square root of 63, 5 square root of 63 over 63.
I think it's 122.
Say it again?
61 times.
Oh, it's 122. 122. So that's
61. 25 over 61.
Sorry. 25 over 61. 61. 61. 61.
I'll strip
Go ahead.
1 minus pi over 61.
So it's 11. Right.
Okay.
So right. So we have 1 minus. Thank you. 1 minus 11 over 61. The 1 is 61 over 61. Minus 11 over 61.
Okay.
61 minus 11 is 50 over 61, and then you just roll the rest of it. Yeah. But again, the calculator just saw that for you. And it's the plus. Same thing for tangent. All right, you just use the formula for tangent. Tangent is 15 over 8. What's the rest of this stuff, right? Triangle,
It's a quadrant.
quadrant 3, alpha. Tangent is
Up in the pages.
815. 815. I think it's 17. Is it 815, 17? Z squared equals 225 plus 64, 289 is equal to, is it 17?
Yep.
17. All right. So then sine of this angle is 15 over 17. We're in quadrant 3. So everything's negative, right? Cosine of this angle is 8 over 17. That's also negative. And then, yeah, it's all formulas from there on, right? So then it's the square root plus or minus. Again, it's the plus because you're in a triangle. 1 minus, and you really only need the cosine, right? These formulas don't involve sine. So it's 1 minus, in this case it's plus, 8 over 17 all over 2. Calculator and reduce. And this one is 1 minus 8 over 17 over 2. And then tangent, you just take the ratio of those two things. For the first half, for the buzzer, right? So sine squared alpha over 2, you want to show that these two are equal. That's funky. So sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine theta over 2. If I square both sides, right, then the sine squared theta over 2 is equal to 1 minus cosine theta over 2. So they're doing some really bad stuff here that I don't want to do. Use the appropriate half-angle formula and rewrite the left inside it. Rewrite the expression from the previous step by multiplying, so they want us to do this. So rewrite the expression by multiplying the numerator and denominator by this special thing. So if you do 1 minus cosine theta over 2 and then multiply it by their suggestion, this is what we call math magic. Somehow they just said, just do this. Right? And if you do that, then you get secant theta minus cosine theta secant theta all over 2 secant theta, right? But what's cosine times secant?
1.
That's 1. So then you get secant theta minus 1 over 2 secant theta. You get the answer. Let's see if we can just answer the questions. Use the appropriate half-angle formula and rewrite the left side of the identity. Do they just want this? Hopefully they just want this. So then this goes here, 1 minus cosine theta over 2. And then we multiply by secant theta over secant theta. And then, oh, they don't want us to simplify. What do you think they want? You think they want secant theta minus cosine theta secant theta over 2 secant theta, right? And then hopefully things just, because these cancel because of a reciprocal identity. Because cosine and secant are reciprocals. I think the rest is just the answers, right? Yeah. All right, we'll take a break there. We'll come back and we'll solve some equations. That one went pretty quickly. Looks like we are headed out of here super quick after we do some identities.